I guess the first step of our experiment, we're going to write out all the steps. These are the ones we went over in class. And then we're going to go over the results, at least, of the second and third mixtures. All right. So basically, we're going to be learning how to use a table of that tells us the solubility of some of the common compounds in water. So we'll come back to this in a second. First, we have to define some terms here. Where we have to know what the word soluble means. So if something is soluble, it is able to dissolve. And typically, we usually mean in water, but in theory, you could be soluble in other substances. But in solution chemistry, typically we're dealing with water. In water, often to form a solution. And a substance with low solubility does not dissolve strongly to form a solution. All right, so let's think of some examples. So for example, table salt is soluble in water. So we know that because when you add a bit of salt when you're boiling water to make pasta, you don't necessarily see all those grains of salt at the bottom. They dissolve apart, separate. They dissociate, actually, into sodium ions and chloride ions. However, something with low solubility might be, if we're thinking about cooking, maybe you could think about oil. Oil, it has low solubility in water. It doesn't mix well to form a solution. All right. So we went through some chemical reactions and we just looked at the results here. So the first thing we did is we mixed some lead nitrate and we mixed some potassium iodide. And we saw what happened here. Both of these are ionic solutions. So that is to say we have some lead nitrate, which is PbNO3, and that's solid. And that makes lead ions in solution, and that's what's floating around in here, some lead ions. And in addition, there's some nitrate ions. And there's 2 lead nitrate ions for every 1 lead ion. So we can see here that, that we can't really see the lead or the nitrate. None of them refract or reflect light or absorb light significantly, so as a result, it looks just like a clear substance. And that's typical of solutions. Not necessarily that they're always colorless, but that a solution typically is clear. You can usually read through it, even if there's a color. All right. So when we mix, and the potassium iodide over here, we had added some solid potassium iodide into a solution, and although the potassium iodide dissolved as well, and that formed potassium ions that were aqueous, and iodide ions, which were also aqueous. Now if we see what happens if we mix some of this, we're going to add some of this lead nitrate in here. And we'll add the potassium iodide as well, and we can see before our eyes that a yellow precipitate is formed. Something fundamentally different is in this solution. Now it's a little difficult to see right away, and that's because it's mixed quite well, so I'm going to set it aside to let it settle a little bit. And so what's happened here is that some of these ions have mixed together to form something that is a low solubility compound. And they've formed a solid that eventually is going to form a precipitate, solid precipitate at the bottom of our test tube. I should probably add that to the definition of low solubility. Something that doesn't dissolve strongly to form a solution and will form a precipitate. Okay. So then we're going to see if we can figure out, well, what the heck this yellow substance is that happens to have formed and is floating around in this solution. Okay. So to answer that question, we're going to look at what combinations of these ions, oops, jeez, which out of all of the ionic products, that's these four, do any of them match and have low solubility as a compound? So what that means is I'm going to look on my common compounds table, and I'm going to look at some combinations of negative ions, like these guys, and positive ions, and see if these combinations either give us very soluble compounds that exist in solution, like, say, potassium and iodide, or if they mix together to make something insoluble, like this substance that is going to precipitate and settle out of this solution. Alright, so let's start with the combination of iodide and potassium. So we already know, or we get the observation, that this should form a solution. These should be soluble in water, because we don't see any potassium iodide floating at the bottom. And so if I look on this table, I could look for either potassium or I could look for iodide. I can say iodide, oh, I found it here, is one of the negative ions. And so I can really cover up the rest of this table, like so. And when I do, I'm really looking at, okay, well, what combinations of things with iodide, which positive ions can mix together to form soluble substances or low soluble substances. And so I would, if I'm looking and trying to answer a question about potassium and iodine, I want to know if it's soluble. I would say, well, does iodine mix with potassium to form a low solubility compound? Well, potassium is not one of the positive ions mentioned. It's one of the other positive ions. And so potassium would be up here with the all others, and therefore is soluble with iodine, or iodide. And as a result, we get this clear solution because they were soluble, they dissolved. Okay. I could also have done that by starting with looking for sodium, or pardon me, potassium, and then finding out what negative ion makes potassium. Oh, it looks like it's always soluble with every negative ion. Okay, so I could have concluded that potassium would not combine with iodide to form one of these precipitates, these solids. I could also conclude that potassium won't bind with nitrate to form a precipitate. So the only real combination that's possible is either the potassium with the nitrate, the potassium with the iodide. We just checked those, and those don't work. Or the iodide nitrate with the lead, I guess, or the iodide with the lead. So let's see if we can find lead in the positive ions somewhere. So let's see what we've listed here. So we have the alkali ions all listed here, and they must have some rule. Hydrogen ions, ammonium ions, okay. All. Well, I guess that includes lead. That includes my lead 2 ion. That's all. And it mixes with a nitrate, and when it does, again, the compound is soluble, which confirms what we saw with this lead nitrate solution. It's colorless. We don't see any salts or anything like that settling in here. So the only other combination of ions is lead and iodide. And so we saw down here that iodide, when mixing with lead 2 at least, the valence lead 2, forms a low soluble compound. So that we can say that lead ions and iodide ions match and have low solubility. So as a result, when we have all these ions on the left, our lead ions, which are aqueous, and our 2 nitrate ions, which again are aqueous, our potassium ions, you mix them all together in a bowl, well, they are going to form some lead iodide solid. And that's the solid that we saw. And that solid sinks out of the solution given a bit of time. But the remaining ions, the 2 nitrates and the iodide, remain in the solution. And so we ended up skipping the net ionic equation. I want to come back and talk about that. I might write it here, why not? The net ionic equation is what we get when the substances that are shown on both sides end up canceling out here. So to find the net ionic, oops, not the iodide. Oh, iodide shouldn't have been here, sorry, that should have been potassium. Potassium does cancel out with this potassium. Then that leaves lead, AQ, plus iodide, and this is the actual reaction that's happening. These 2 ions are meeting together to form a solid lead iodide. And this was the precipitate. The precipitate was the lead iodide solution, or solid. Is it settling at all? Let me just check here. No, I'm going to let that settle. We'll come back to it. But lead iodide, you can start to see a little bit of this separation happening here as you have a clear section of solution that is obscured by the, and you can start to see the precipitate sort of forming a little bit. Or rather, you can see the difference between the top as it settles and the precipitate lower down. In addition, I don't know how much I can show this, but you can also sort of see some precipitate gathering at the bottom here. Maybe you can't see that so much on video. All right, so the challenge now is we're going to see 2 other conditions. We're going to mix some barium chloride and some sodium sulfate, and we're going to see what happens there. And so let me just get these solutions aside. So we got barium chloride. That's these guys. This barium chloride here. Barium chloride. And what do I need to mix it with? Sodium sulfate. So you can see we have sodium sulfate over here. Okay. So these 2 mixed together, we're going to see if they make a solution or a precipitate as well. So you can watch as I add some and see if we see any obvious precipitate forming. And we do. In this case, the precipitate is white. And it's kind of milky. And we're going to see if that settles as well. So I guess what I want anybody who's watching to know is that when we mix these, for sure we get some white precipitate. And the question now is, well, what is the precipitate? Can we find what ions are floating around in here and then see if any of the ions pair up such that they're going to form an insoluble compound. In this case, it'll be white. Okay, and that's the challenge. And okay, that's our sodium sulfate and our barium chloride. And the next solution is copper chloride. And that's this guy, copper chloride and sodium carbonate, which is this guy. I'll get this all out of the way. 1, 2, 4. Alright, so this guy is our sodium carbonate that was used to make this stuff. And this is our copper chloride. Alright, so for our last solution here, we'll take a bunch of this stuff, pour it into. And so here we have a solution. It has a color to it. It's sort of bluish. So it already has a color, but remember, it's not the color necessarily. Solutions can have colors. But what we're looking for is we can still see through it and read through it. It's a little hard to see through the video here. Also, there is something else going on with the solution we'll talk about a little later. So you can see that this is not opaque. You know, I can read through it. I can see the words a little bit there, reflecting through. Alright, so where's that test tube? Here it is. Now when I mix them, it's a little bit more subtle of a reaction. As you even put a few drops in, you can start to see precipitate, a cloudiness, a blue cloudiness forming. And oh, you can really see it of this one actually. You can see these blue clouds sort of appearing. Try and focus on that, see if that resolves it any better. Yeah, there's a milky kind of weird precipitate formed in here. Okay, so each of these mixtures form some precipitation. And really our efforts now are to figure out, okay, can we fill out all of this and find the identity of the, oops, not the solute, precipitate. Okay. So I wish you luck with that, trying to solve the identity of each of these precipitates.